Here is a pattern made from square tiles. Let's make a table that relates the number of squares and the figure number. So figure 1, you can count the number of squares. There's 5. Figure 2 has 10 squares. Figure 3, 15. And figure 4 has 20 squares. If I want to write an expression that relates the number of square tiles to the terms f, I notice that the number of squares is always 5 times the figure number. So I write it as 5f. I can verify the equation by substituting the values in my table. So if f was 1, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. If I were to try to figure out which figure has 225 tiles, I would just set up the equation like this and then solve for it. So 225 divided by 5 would be 45. Graphing equations. So to graph an equation like y equals minus 2x plus 7, I need to make a table of values, choose values for x, and substitute it into the equation. If x was 0, negative 2 times 0 plus 7 is just 7. If x was 1, negative 2 times 1 plus 7 is 5. If x was 2, negative 2 times 2 plus 7 gives me 3. This gives me 3 ordered pairs that I can plot on my grid. So 0, 7 would be a point here on my grid. 1, 5 would be here. 2, 3 would be here. So here's my linear relation. I notice in my table that as x goes up by 1, y goes down by 2. So I can keep extending my points on the graph even without substitution. Does each equation describe a vertical, horizontal, or oblique line? How do I know? Well, the first equation, I notice there's only an x variable, so I know that's going to be a vertical line. In the equation 2, there's only a y variable, so I know that'll be a horizontal line. In the third equation, 2x plus 9, there's only an x again, so it has to be a vertical line. The only way I get a oblique or diagonal line is if the equation has x and y. Matching equations. Start with the easy ones. So I know that y equals 3 is going to be a horizontal line, and the only one is a graph 2. X equals minus 3 is going to be vertical, so it has to be the third one. If I want to check which one matches y equals x plus 3, let's try making a table. I need to know what values exist on this line. So I know 0, 3 will be on the graph, 1, 4, and 2, 5. And I notice graph 1 goes through these 3 points, so it has to be graph 1. By process of elimination, graph C should be the last one here. But just to check, let's make a table. X plus y equals 3. So if x is 0, y has to be 3. 0 plus 3 equals 3. 1 and 2. 2 and 1. And this happens to match graph 4. This graph shows the volume of water in a cistern after 10 days. How many days does it take to use 200 liters of water? If I use 200, that means there's 800 liters remaining. This happens at day 8, based on my graph. I'm interpolating because I'm looking at a value in between my 0 and 10 days. Estimate the volume of water after 22 days. Well, this goes past my graph. It's about here, so I can extend my line. It's not perfect, but based on this, it looks like it's about 400 liters remaining. This is extrapolating because I'm going beyond, or I'm extending my graph to make this estimation. I can be a little bit more precise. I noticed after 10 days, the water level goes down by 250 liters, which would mean that at 20 days, it's going to be 500, and 22, it'll go down by 50 more. So 450 liters. How much water is used in the first 14 days? Again, I can extrapolate. 14 is about here. So it looks like if the level is at 600, I used maybe 400 liters. To be more precise though, again, I notice it goes down by 250, or 250 liters are used every 10 days. which would mean at 14 days I've used up 350 liters. Again, these assumptions only make sense if this is a linear relation.